Welcome to this lab. This lab is based on a use case that will walk you through a data pipeline across the most relevant so-called data services on CDP, Cloudera Data Platform. Those are the list of data services that we are going to use inside this pipeline, and the pipeline is structured in this way. We gather stock information from a public site, then ingest with the data flow, and then transform with data engineering, basically Spark, to create an iceberg table and to visualize this table with the so-called data visualization service. Those are the prerequisites that you are meant to satisfy before starting, and that's the GitHub link of the project to be cloned, so that you will download locally a couple of resources that you're going to use it. So here I'm showing you a very simple GitHub clone, and after let's go to the step 2 to create an Alpha Vantage key, allowing us to access from our CDF those information about stocks, so the time series of the stock. Here you will find an example of how to fill up required information and to get a demo API key. Okay, so I think that's standard stuff. And then once you got this key, you can start working on actual lab by using a key cloak instance to do single sign-on. Our suggestion is to use an incognito window, so not to having any trouble with previous cookies. And so insert your username and password, and then you will be brought into this landing page of the CDP platform, where you can then change or set your so-called workload password. The workload password is nothing but the password of a CDP user that is needed to access the underlying data lake storage, which in this case is based on S3. So the CDP basically map the credential of the CDP user into an Amazon role, so to get read and write access to this role. So let's go to the next step, which is to create the Cloudera data flow to ingest from Alpha Vantage site the stock information. So we jump into the Cloudera console. Here the list of all the data services. So now we are impersonating the role of the data engineer, data developer. You can see there is a central catalog that store all the flow definition. We will import the flow definition that we just cloned from the GitHub repo. You may remember the previous step. And so we give this flow a name. We can insert a description to make it more meaningful, and then we select the local file that we just downloaded locally. Yes, that's the one. Yeah, we have it locally in our laptop in this case. And so that's a JSON definition, gets translated into a CDF data flow. So once imported into the catalog, successfully imported, we can then take a look over it, and then it's time to deploy it. So to make it running, to make it able to poll and to request from Alpha Vantage key the stock time series. So we choose now from the catalog an environment where the platform is running. So this is, in this case, the platform chosen for our lab. And then this will land us to a wizard asking for deployment information, like the deployment name, okay? Which name do we want to give to this data flow instance? Okay, click next. Here there are some other configuration parameters, like to start automatically the flow after the deployment. And then here there are some parameters that are used by the flow that we will see later on to make this flow logic running, able to retrieve the stock information from the website and store it into the data lake storage. We also add our own alpha key, API key that we just gathered from the site. And then here you can see there are also information about the stocks, tickers that we want to download. Go to the next section of the wizard, and here we define the sizing of the deployment. So extra small refers to the sizing of the underlying pods that will implement the flow. We can decide some auto-scaling policy, so to make the deployment more elastic and capable. Here are performance indicator, basically monitoring metrics, and here is the review page. In the review page, you have a summary of your configuration alongside with parameters and sizing and scaling, and then it's time to deploy. The deployment page, we shall see, now it's deployed. The green tick meaning that deployment went fine. That is an indication that the flow is actually working and bringing stuff inside the data lake storage. Here we see some details of the deployment currently ongoing. So all the parameters that we set initially, and here there is a chance to see the actual flow logic which is currently running inside this flow on this nice visual no-code canvas. We can see the so-called process group, grouping all the actions, what we call it in NiFi terms processors, that are pre-implemented action logic related to, in this case, to how to invoke Vantage site API. For instance, here you will fill out the URL of the API, just as an example. And another part of the logic of this flow is related to, of course, transform the streams gathered from the website and to store it into the S3 bucket that we are using as a data lake storage. So here, after some transformation, in this specific processor, you see the path. That is basically nothing but the parameter that we used to enter while deploying the NiFi flow. And so this is, let's say, the overall structure of the process. And with that, we can come back to the deployment manager page, because now it's time to suspend it. We don't need this flow running forever, because hopefully we already gather some stuff inside our bucket, our data lake storage. So here we suspend the flow, and now it's suspended. Fine. For a while, into the underlying Amazon S3 bucket, in order to take a look, just for our knowledge, on the structure of the files that we just retrieved thanks to the CDF flow. So let's take a look over a single file representing a single time series of a single stock ticker. Okay, because you may recall that we entered 4 different ticker stock parameters inside, and that's exactly the time series for IBM stock. Jump into the step number 5, which is creating the iceberg table that will host the so-called, let's say, curated layer of the information that we gather in raw format inside the bucket as files. So we will use the embedded SQL editor, which is included into the so-called data warehouse service. So you will have just to select your data catalog and click on the associated so-called data warehouse service, which includes an icon to bring you to the U editor, where you can insert your SQL code that will allow you to create the iceberg table. You can, okay, first step is to create the database, of course. We used to add your username in order to keep it unique. Yeah, now we can copy paste from the GitHub repo the statement to create your database. That of course will update the Hive catalog, which is of course integrated into Impala as well. And then come back to the create table DML code. You may notice that this is standard create table code, but there is a store as iceberg. This is of course a new kind of statement that has been added to SQL, Impala and Hive SQL in order to be able to handle iceberg table format as SQL code. And with that, we arrive to step number 7, where we implement a data engineering job in Spark, in this case, to take the raw files that we ingested with the data flow and merge those data periodically into the iceberg table that we just created before. CDP console, let's click on data engineering tile and land on the data, so-called Cloudera data engineering service, which is basically a Kubernetes-based Spark and Airflow service. Let's create a job out of this UI. Let's select Spark 3. We can review the configuration option on the GitHub repo. Scrolling down, yes, job type, we have to choose Spark 3. We can choose, yeah, and then switch to the job name, the application name, basically, which is our user as a prefix to make it unique. And then use, let's say, this naming configuration. Now it's time to upload the actual Spark application. And you may recall that we just downloaded with the GitHub repo initially. So this jar file is just under the root of your cloned repo locally. And that means that you can upload this jar file with this wizard, selecting it and just associating with the resources. Resources is a local repository of jar files or Python files that makes you, basically it's a way to avoid uploading each time we want to submit a job a new jar file, unless we want to of course have another version of that application. Then it's time to set up the main class that will be started by Spark and fill out with some arguments, which are basically parameters that are used by the Scala code inside this application to look for raw files into the bucket where Dataflow has saved the files and write it into a database and a specific table inside the database. Now run, basically submit this application as a job. the job has been submitted, we can take a look over the job section of this UI, looking at the run ID that has been assigned to this job and looking at the job in a live tail fashion. First Spark events and then later on the actual standard output that has been printed from the code itself, just to track the advancement of the Spark application as the job is running. Now the job has completed with success and the temporary directories has been processed. So basically the logic inside the job creates new folders, let's call it folder, new nodes inside the bucket to move the files that has been processed from the bucket and written into the table. And so you can take a look over the files if you have an access to the Amazon console. Now we have a data engineering job that is able to periodically transform raw data into, let's call it curated data, into an iceberg table. Now it's time to use data visualization to convert those data into meaningful information that can be shared and used by the data analysts. Come back to the CDP console, look for data warehouse section, and in this section you will find the data visualization application. You choose the one assigned to you according to the lab instructions, and then you will find a summary landing page where you can start by creating your dataset, clicking on data, choosing your own connection to the data warehouse that you have been used to create the table. You can set a title to this dataset. Basically, a dataset is a semantic layer over existing tables that will be used by the dashboard to visualize. In this case, we create a dataset out of a specific table. We could use SQL code to customize the dataset creation, and then we land into this canvas that basically is our starting point to design the visual presentation of the data. You will see there is a default representation as it is in tabular form, but here on the right hand side we can choose which dimension and measure our visualization would be based on, and such dimensions and measure are automatically defined by the tool whenever the dataset is created. Let's see how it looks by aggregating stock volumes by ticker, and let's change the appearance of this default visualization into something more insightful, like a bubble representation. Now we can move this canvas to a public visibility in order to share it as a URL with external, for instance, groups, collaborators, and then that's basically the final result saved into the CDP platform and exportable with this URL to external user. Let's try to see it. Yeah, with a specific, in this case, public URL. Of course, that can be profiled. That we basically completed our data pipeline. Let's dig a little bit more into some specific iceberg feature, in our case with the so-called time travel capability of iceberg. So let's come back to our SQL editor, and use some specific iceberg SQL statements that has been added to Impala and Hive to support navigating in SQL the history of all the different snapshots that iceberg as a table format preserves when a table state is being modified. So in our case, we are running Spark jobs that periodically merge and so update the state of our table. In this case, we see here a single snapshot ID, meaning because we just run a single run of the Spark job. So the state of the table has just changed once. And so you can see here we can use the snapshot ID provided by the describe history command to query the table to a specific point in time identified by a snapshot ID or by a timestamp, so to have a consistent view of the state of the table also in the past, basically. Okay. Now, to be able to appreciate iceberg time travel feature, of course, we need to update our table. And we will update this table by adding a new stock ticker time series. And so to do that, we will come back to the CDF data flow, the ingestion flow. We will add a new parameter inside the deployment section. In this case, a stock ticker of NVIDIA stocks, NVIDIA company. And then we will redeploy the flow, so to bring into our data lake an additional time series, which we will use with our Spark data engineering job to update our table in the way that we will create and trigger the creation of a new snapshot inside Iceberg. And so, and then we will come back to you and we'll rerun the describe history that we have seen just before. Let's come back to the CDP console. Let's come back to data flow. Let's we will find our flow in suspended state. We left in this state before. Now it's time to manage this deployment and change, as we said, change the parameters to add the additional stock ticker, in this case the NVIDIA one, so to instruct Vantage API on, let's say, retrieving also this additional time series. Now the changes has been submitted. Now it's time to redeploy this flow. So restart it, and then we should wait a couple of seconds that the deployment request has been accepted, and now the flow is running, and after a while a visual sign of activity should appear on the graph right now. It means that the flow is actually retrieving reading and writes bytes. So if we switch back to AWS console, S3 console, we should see a new key on our bucket with the newly retrieved files, in this case, and the latest of which should should include the NVIDIA stocks. Now let's come back to data engineering part. So now we have the files, the new files. Now it's time to rerun the Spark job that transforms those files transforms and merge those files into the existing Iceberg table. Now the job has been submitted, and as we did it before, we can take a look over the logs. Log of this starting job. After a while it will appear the standard out as well, so that we can also trace the actual code execution Now the job is running, and we can see the number of executors over which the job is distributed, and now the job is progressing, merging the data, the files into specific data frames in a temporary table, and then merging this temporary table into our iceberg one. So now it has completed right now, so with success. And so we can come back to U and rerun the previous SQL describe history statement, and we should see, yes, another snapshot ID, because the table has been changed right now with new data. And so if we reissue the previous select statement with the previous snapshot ID, we should see the previous state of the table. Although the table has been physically changed, we still can appreciate a different consistent state of the table, while instead if we query the table with the newest snapshot ID, then we will see the latest, in this case, state of the table with NVIDIA series included, as well as which is basically the same state that we should find with the standard SQL query without any specific snapshot ID as a predicate.